Welcome to the Explainer. Today, we're diving into something that's right under our feet but almost completely invisible, the incredible hidden system that keeps our cities from turning into lakes every single time it pours. It seems like a pretty simple question, right? You see a storm, water rushes down the street, and then poof, it's gone. But where does it actually go? See, in a modern city, all that water isn't some nice gift from nature. Nope. It's a huge engineering headache. Just think about it for a second. Natural ground, it's like a sponge. But our cities are covered in concrete, asphalt, and buildings, what engineers call impervious surfaces. The water can't soak in, so it has nowhere to go but to run off. And if you're not ready for that runoff, you've got a flood on your hands. And it happens fast. So to solve this problem, our cities rely on this. Well, this giant, hidden circulatory system. A network of pipes and tunnels. And here's the crazy part. Building it doesn't start with a shovel. It starts with a prediction. All right, so let's get into how this actually works. Before you can even think about digging a trench or laying a pipe, you gotta know exactly how much water you're up against. You can't just, plan for a lot of rain. No, you have to engineer for a very specific, very calculated kind of storm. And that's where this idea of the design storm comes in. Now, you've probably heard the term 100-year storm, right? Well, it's a little misleading. It doesn't mean it only happens once every century. What it really means is that it's a storm so intense, there's a 1% chance of it hitting in any given year. It's a statistical benchmark, a kind of worst-case scenario that engineers use to figure out, okay, how big do these pipes really need to be? Okay, so you've got your design storm, but the next big question is how much of that rain actually becomes runoff? Because let's be real, a grassy park and a giant paved parking lot are going to handle a downpour very, very differently. To figure that out, engineers use something called a runoff coefficient. And you can just think of it as a sponginess score. So look at this. Pavement gets a score of almost 1, like 0.95. That means pretty much all the rain that hits it is going to run off. But a lawn, it's down around 0.1 because most of the water soaks right in. And this right here, this single number, is the key to understanding why our cities are so vulnerable to flash floods. So how do you actually put all these pieces together? Well, for smaller areas, engineers use this really elegant, almost surprisingly simple formula. It's called the rational method. You literally just take that sponginess score, the runoff coefficient C, and you multiply it by the rainfall intensity, I, and the size of the area you're draining, A. And what you get is Q. The peak flow. That's the magic number. It tells you the absolute maximum amount of water your drain is ever going to have to handle at one time. All right, so you've done the math. You know how much water is coming. Now, what do you do with it? Let's look at the actual building blocks, the engineer's toolkit for managing all that flow. So water basically gets moved in one of two ways. First, you've got your open channels. Think of those grassy ditches you see along the highway. They're pretty simple, and they can handle a ton of water. But in a dense city, the real hero, the absolute backbone of the whole system, is the hidden network of underground pipes, all flowing thanks to good old gravity. So how does all that street-level water get into those pipes in the first place? Well, that's the job of inlets and catch basins. You know them. They're those metal grates you see on the side of every street. They are the official gateways, the entrance point connecting our visible world to that vast, invisible network underground. But gravity has its limits. It can't pull water uphill. So what do you do with low-lying spots, like highway underpasses? That's where pumping stations become absolutely critical. They're basically just powerful elevators for water. They lift it from those low points back up to a higher elevation so gravity can take over again. Without them, every underpass would turn into a dangerous, flooded lake during a big storm. And this level of planning, this engineering foresight, it goes way beyond just managing water. It's about keeping people safe. I mean, look at this. For the big ponds and lagoons that hold all that excess stormwater, the design manuals require stuff like protective fences and even escape ladders every 100 meters or so. It's just a powerful reminder that this isn't just about protecting property from floods, it's about protecting human lives. So, having a great design on a blueprint, that's just the start. Actually turning that plan into a real functioning system in the ground, oh, That is a whole other level of complexity. Every single one of these projects goes through a pretty long and intense life cycle. It all starts with what's called a reconnaissance study. Basically, just figuring out if the project is even possible. Then you move into a preliminary design, and after that, a super detailed design. Only then can it be put out to tender, where construction companies bid on the job. And even after it's built, it has to pass all these rigorous inspections before it's finally approved and handed over to the city to maintain. And you better believe that along every step of that journey, the real-world complexities just pile up. I mean, you have to coordinate with every single other utility company. Think about it. Power lines, gas mains, telecom cables, they're all buried down there too. You have to follow strict environmental laws, get approvals from a whole web of stakeholders and agencies, and you have to plan for the long-term operational costs. It is a logistical masterpiece when it all comes together. And I don't think anything sums up the sheer level of accountability here better than this one sentence. It's from the Abu Dhabi Stormwater and Drainage Manual, and it says, "Department design approval does not guarantee taking over of assets." Let me translate that for you. It means, hey, developer, just because we said your plan looks good on paper, it doesn't mean we're going to take responsibility for it if you build it poorly. Wow, talk about a powerful statement. It's all about making sure these systems are built right and built to last. So why does all this matter? I mean, we're talking about a whole world of pipes and ponds and pumps that most of us will never, ever see. Well, it matters because this invisible system is basically a protective shield for our entire way of life. And make no mistake, these are not temporary patches. We're talking about legacy infrastructure, the big stuff, the reinforced concrete pipes, the major culverts. They are designed to last for 100 years, a century, sometimes even longer. That's just an incredible investment in the future, built on a vision that goes way, way beyond our own lifetime. So the next time you walk down the street and see one of those drains, remember, it's not just a hole in the ground. It is the tiny, visible tip of an absolutely enormous, hidden world. It's the culmination of the science of prediction, the art of engineering, and the incredible discipline of long-term planning, all working together to keep our cities safe, dry, and functioning. Kind of makes you wonder, doesn't it? What other huge, invisible systems are humming along right now, silently, 24/7, just to keep your city alive? That's it for this explainer.